So, next example tayo. So, determine the forces of P, F, and T required to keep the triangular frame ABC shown in equilibrium. So, meron tayong given na triangular frame. And para maging equilibrium sila, kailangan nating i-determine kung ano yung value ng force T, and force F, and force P. Okay? So, kapag triangular frame or truss, we can use yung ating summation of moment is equal to 0 to determine the forces. Okay? So, saan tayo pwedeng mag-moment para makuha natin yung mga forces? So, itong force T, para makuha natin, pwede tayong mag-moment sa point B. Okay? Yung force P and F natin is concurrent siya sa point B, kaya hindi natin siya pwedeng i-moment doon. So, ang may moment lang natin is itong 3,600 and itong force T. No? Pati itong 1,200, hindi natin ma-moment kasi concurrent siya sa ating point B. Okay? So, pwede natin makuha yung value ng force T. So, summation moment at point B is equal to 0. So, ano yung may moment natin will be yung 3,600. So, clockwise positive. So, 3,600 times yung moment arm niya, that will be 12 feet. Minus, so yung force na T naman, so counterclockwise siya, kaya minus, so that will be T times 8. Okay? That will be equal to 0. So, solving for T, that will be equal to 5,400 pounds. Okay? So, nasolve na natin yung force T. Solve naman natin ngayon yung force P and force F. Okay? So, saan tayo pwedeng mag-moment para ma-solve natin yung P or yung force F? So, kapag nag-moment tayo sa C, mag-moment yung F and P. Okay? So, magkakaroon tayo ng dalawang unknown. Okay? Mahirapan tayong mag-solve doon. So, kapag dito naman sa A tayo nag-moment, so, same din, magmo-moment yung ating force F and magmo-moment din yung ating force P. Okay? So, dalawang unknown ulit. Pwede naman natin gawin yon, pero mas matatagalan yung ating pag-solve dito. Okay? So, yung isang technique para makuha natin yung force P, maghanap tayo ng point kung saan yung isa sa kanila is hindi magmo-moment doon sa point na yon. Okay? Na yung force P is pwede nag-moment siya doon sa isang point, pero yung force F hindi. Parang ganon. So, in this case, pwede nating i-extend yung ating force P sa ating yung line of action ng force P, pwede nating i-extend. Okay? So, example here, itong force P, pwede natin siyang i-extend yung kanyang line of action hanggang ma-intersect niya dito sa ating point A. Okay. So, let's call this point D. So, magkakaroon tayo ng X and Y component. So, yung force P natin magkakaroon ng PX and this is PY pala. PY and PX. Okay? And then, yung force F natin, pwede rin natin siyang i-extend yung kanyang line of action, di ba? So, we can extend yung line of action. Hanggang mag-intersect siya dito sa line of action ng force T. So, let's call this point E. Okay? So, ayan. Ngayon, pwede tayong mag-moment sa point D. Hindi na mag-moment yung ating force P kasi concurrent siya sa point T. Ang mag-moment na lang na unknown will be yung force F. Okay? So, ang technique dito, maghanap tayo ng point kung saan isa lang yung unknown na nalalabas sa ating equation. Okay? So, kapag dito sa point D tayo nag-moment, so magka-cancel yung force P natin. Ang magmo-moment na lang na unknown will be force F. Okay? Ganon. So, in this case, dito sa ating point E, magkakaroon din tayo ng EY and EX. Okay? EX. So, try natin mag-moment sa point D. So, summation of moment at point D will be equal to 0. That will be clockwise, positive. So, cancel na yung point P natin. Hindi yan mag-moment. Ano yung pwede nating i-moment? That will be 3,600 times. So, kailangan natin kunin yung distance nito. So, given naman yung slope natin, class, no, na 3:1. So, by ratio and proportion, makukuha natin yung whole distance ng ating CD. Okay? So, yung whole distance natin ng CD. So, this will be CD. So, by ratio and proportion, meron tayong triangle na 3:1 and CD is to 8 feet. Okay? So, pwede nating makuha by ratio and proportion. That will be 3:1 is equal to CD over 8. Okay? So, solving for CD will be equal to 8 times 3, that will be 24 feet. So, yung CD pala natin will be 24. So, kung 24 yung CD natin, yung DA natin will be 12 feet din. Okay? So, 12 feet pala. So, that will be 3,600 times 12 feet. Okay? So, magiging negative to, class, kasi counter clockwise. So, negative itong ating 3,600. And yung 1,200 naman, that will be clockwise. That will be positive plus 1,200 times the distance, that will be 24. Okay. Yung force F natin, hindi natin may moment. Okay? Kasi concurrent siya sa ating point D. And then, yung force F natin, which is unknown, yun yung pwede nating moment sa ating point D. Okay? So, we can use yung ating X component na lang if kung in-extend natin yung line of action ng ating force F hanggang dito sa point E. And kapag ito yung ginamit natin, no? Ito yung gagamitin natin na mag-moment doon sa ating point D. So, yung EX, hindi na siya mag-moment doon sa ating point D kasi concurrent yung EX natin sa point D. So, yung pwede nating i-moment is itong EY. Okay? So, EY will be clockwise. So, plus ulit yan. Plus EY. EY or yung force F natin, that will be. So, ano yung distance nito? That will be equal to. So, given yung slope niya ulit, that will be 2:3. So, pwede nating by similar triangle, ratio and proportion, that will be 2/3 is equal to 2/3 is equal to 8 over CE. Okay? Solving for CE, that will be equal to 12 feet then. Okay? So, that will be 12 feet. So, 12 feet din pala ito. So, that will be EY natin or yung FY natin. So, let's call this FY na lang para hindi tayo malito. Nagkaroon ng dagdag na force. So, this will be FY. FY and FX. So Fy yung magmo-moment sa ating point D. So that will be 24 plus 12. So that will be 36. Okay? So yung Fy pala natin is equal to, so yung sa summation moment of D, that is equal to 0. Okay? So yung Fy natin, is equal to, so yung component ng F, that will be, ano yung hypotenuse ng 2 and 3? That will be square root of 13. Okay? So square root of 13 yung ating hypotenuse. So yung Fy natin, that will be equal to 2 over square root of 13F. Okay? Tama ba? So itong 2 over square root of 13 times F, substitute natin dito sa ating Fy. So masosolve natin yung force F natin. So solving for F, so class, substitute nyo doon sa Fy natin. Ha? So solving for F, that will be equal to 721.11 pounds. Okay? So nasolve na natin yung force F. So next naman is yung force P. Okay? So to get the force P, pwede tayong mag-moment along E. Kasi yung force F natin is hindi na siya mag-moment sa E kasi concurrent siya. So concurrent yung force F natin, concurrent din yung force T natin. So ang pwedeng mag-moment is yung P. So makukuha natin yung P and other forces. Itong 3,600 and itong 1,200. Okay? So solving for force P, summation moment at E is equal to 0 clockwise positive. So force P will be, ano yung may moment natin sa force P? So kung diniretso natin yung line of action ng force P going dito sa point D, so ang magmo-moment na lang is yung ating PY. Okay? Naintindihan? So kapag in-extend natin yung force P natin, and ito yung gagamitin natin para mag-moment sa E, yung PY na lang ang mag-moment. Kasi yung PX natin is concurrent siya sa ating point E. Okay? So PY will be, yung PY is yung Y components ng force P natin. So that will be, so itong slope natin is 3:1. So yung magiging hypotenuse niya will be equal to square root of 10. Okay? That will be square root of 10. So i-moment na natin. So P, that will be, yung PY lang ang gagamitin natin. So that will be 1 over square root of 10. So 1 over square root of 10 P. So multiply natin, ito na yung PX natin, class. So ito na yung PY natin. So multiply natin. So ano yung distance niya? That will be 24 plus 12 will be 36. Counterclockwise siya, class. So kaya magiging negative ito. So negative yan. And ano pa yung mga forces na pwede nating i-moment? Is yung 3,600 and yung 1,200. So 3,600, that will be clockwise. So plus 3,600 times, so 12 plus 12, 24. Minus, so counterclockwise yung ating 1,200 going to E. So minus 1,200 times 12 is equal to 0. So solving for P, makukuha natin yung P is equal to P will be equal to 6,324.6 56 pounds. Okay. Yan na yung ating force P. Next example. So the weight of the trapezoidal block is 7,200 pounds. Acting where shown the figure. So the ground reaction varies uniformly from an intensity of pound per feet at point A and pound per feet at point B. So determine PA and PB. Okay? So meron tayong given dito na trapezoidal block and we have a resultant force or yung weight ng ating trapezoidal block is 7,200 pounds acting 5 feet at point A. And syempre, meron tayong ground reaction. And yung ground reaction natin varies uniformly din from an intensity of PA at point A and PB at point B. So, paano natin mahanap yung PA and PB? So, given na yung ating weight ng ating trapezoidal block, so, ang kukunin na lang natin is yung reaction niya. So, magkakaroon tayo ng reaction dito. So, using yung ating napag-aralan din sa ating last na module. So, kapag meron tayong uniform loading, so, yung resultant niya is yung area ng ating uniform loading. Okay? So, trapezoid din yung ating ground reaction. So, kunin natin yung area niya at yung resultant niya. So, we can use two triangles here, ano? So, we can divide this into two triangles para makuha natin yung ating resultant force, para makuha natin yung PA and PB. Okay? So, we can divide it into two triangles. So, na-divide na natin into two triangles. So, dito sa two triangles, so magkakaroon tayo ng dalawang resultant forces. So, sabi natin kapag triangle is yung resultant force niya is nag-a-act doon sa centroid ng ating triangle. And yung centroid ng ating triangle will be 1/3 from here, dito sa ating base. So, let's call this RA. And sa kabilang triangle, so ganun din. 1/3 naman ng ating length from point B naman. So, this will be RB. Okay? Ngayon, pwede na nating makuha yung RA. So, sabi natin yung RA is yung area lang nitong ating triangle. So, 1/2 base times height. So, RA is equal to 1/2. So, yung base natin will be yung intensity niya. Dito, yung PA. So, that will be PA times yung length niya or yung height niya. Yung magiging height niya is to 5 plus 7 feet. That will be 12 feet. So, RA will be equal to 6 PA. Okay? And for RB naman is yung area ng isang triangle na ulit natin. So that will be 1/2 times yung intensity nito, PB, times 12 din. So same. That will be 6 PB. Okay? Ngayon, pwede na nating makuha yung intensity ng PB and intensity ng PA using yung ating summation moment at any point summation moment is equal to 0. So, saan tayo magmo-moment para makuha natin yung RA or yung 6PA or yung PB natin. Okay? So, pwede tayong mag-moment dito sa point ng RA. So, yung force na maimo-moment natin dito will be yung 7,200 pounds and RB. So, yung 6PA natin in terms of RB, makukuha na natin yung intensity ng PB. Okay? So, pwede tayong mag-moment at point ng RA. So, summation moment at point RA is equal to 0. Clockwise, positive. So, dito tayo mag-moment. So, kuhanin muna natin yung distance nila. So, yung distance nito will be divide natin sa 3. So, tig 4 feet sila. Okay? Kung 4 yan, 4 din ito, 4 din ito. So, ano yung mag-moment dito sa RA? So, yung 7,200. 7,200 times. So, ano yung distance nito? So kung 4 feet yon and 5 feet yon, so that will be 5 minus 4. So 1 feet na lang yon. So that will be 1 feet. So clockwise siya. And then minus yung RB natin. Pwede nating i-rotate moment sa RA. So RB natin, yung RB natin is equal to 6 PA. So that will be 6 PB. So that will be 6 PB times yung kanyang distance. So that will be 4 feet. Okay? 4 feet. Equal to 0. So solving for PB. So PB now will be equal to 300 feet per 300 pound per feet. Okay? So next, kunin naman natin yung PA. So nakuha na natin yung PB. So yung PA naman. So para makuha natin yung PA, pwede tayong mag-moment at point RB. Okay? So ganun lang din, summation moment at RB will be equal to 0. So ano yung moment natin is yung RA. So clockwise positive, that will be RA. Yung RA natin is equal to 6 PA. So that will be 6 PA times, so 4 feet, it will be 4 feet minus, so counterclockwise naman yung moment ng ating 7,200. So minus 7,200 times, so ilan yung distance niya? So that will be, so kung 7 feet yon and kung 4 feet ito, so that will be 7 minus 4 is equal to 3. Okay, so that will be 7,200 times 3 is equal to 0. Solving for PA, so PA now will be 900 pounds per feet. Okay, next problem tayo. So a pulley of 1 feet radius supporting a load of 500 pounds is mounted at point B on a horizontal beam as shown in the figure. So if the beam weighs 200 pounds and the pulley weighs 500 pounds, find the hinge force at point C. So yung given natin, we have the beam weight which is 200 pounds, pulley weight which is 500 pounds, and our required is yung force at point C. Okay? So yung force at point C natin will be yung RC or yung hinge force at point C. So meron tayong pulley ulit dito supporting 500 pounds. So paano natin isolve yung reaction sa ating point C? So yung beam natin, so this is our beam. Dito sa point A, so magkakaroon tayo dito ng normal force. So this is a roller. So yung RA natin will be only normal force or only vertical. So wala siyang horizontal. Pero dito sa ating point C natin, dalawa yung force natin, magkakaroon tayo ng C vertical tsaka V C horizontal. Okay? So ganoon kasi pin connection siya. So dalawa, meron tayong horizontal at saka vertical reaction. Okay? So para makuha natin yung RC natin, that will be yung RC natin is pwede siyang nag-act depende kung saan. So assume na lang natin na pag ganun yung kanyang reaction. So ito yung RC natin. Okay? So assume natin na papunta siya sa taas. Okay? So first na gagawin natin is pwede natin i-isolate muna yung ating pulley para ma-solve natin. Magkakaroon kasi tayo dito ng yung reaction ng ating cylinder at saka nung ating pulley dito sa point B. Okay? If ito yung beam natin, no? If this is our beam, this is A and this is, so drawing lang natin ng maayos. So kung ito yung beam natin, no? So ito roller, ito is pin yung atin, and yung point B natin, so this is our point B, so A and C. So yung meron tayong yung resultant nito, magkakaroon tayo dito ng vertical force, which is BV, and horizontal force, B horizontal. Okay? So para makuha natin yung BV tsaka BH, makukuha natin yon dito sa ating pulley. Okay? So pwede nating i-isolate yung ating pulley. So if we have here yung pulley, and we have a 500 pounds. Pati dito. So meron tayong lagak na 500 pounds dito. So same lang, kung 500 pounds yon, this will be also 500 pounds. And given yung slope niya, which is 4 and 3. Okay? So 3, 4. So yung hypotenuse niyan, that will be 5. Okay? And ito yung point B natin. So sa point B natin, magkakaroon tayo ng reaction. So that will be BVN BH. Okay? So magkakaroon tayo ng BVN BH. This will be BH and BV. So yung weight ng ating pulley will be 50 pounds. So may nag-act tayong force dito, 50 pounds. Okay? So class, yung direction ng ating BV tsaka BH is a assumed direction. So kapag negative yung lumabas, ibig sabihin sa opposite direction yung magiging sagot natin. Okay? So assume natin na going to the right yung BH, and assume natin na going to the going upward yung BV natin. Okay? So pwede na nating ma-solve yung ating BV and BH using yung summation forces horizontal and summation forces vertical. So summation forces horizontal or X is equal to 0. Going to the right is positive. So that will be BH. Positive siya kasi going to the right. So assume lang natin na going to the right siya. And ano yung mga horizontal force natin will be yung 500. So that will be going to the left. That will be negative. So yung X component, so gagamitin natin yung 4. So that will be 4 over 5 times 500. Okay? And ano pa yung ibang force natin? Nag-act horizontally. So wala na. Is equal to 0 na. So BH will be equal to, so ano yung magiging sagot natin? That will be equal to 400 pounds. So going to the right side yan. Okay? And then summation forces vertical naman tayo, or Y is equal to 0, upward, positive. So ano yung mga nag-act na forces? So that will be BV, that is upward. So BV is equal to, so class, itong BH natin for positive yung lumabas, kaya tama lang yung assume natin na going to the right siya. So tuloy natin, that will be BV minus, so ano yung mga vertical forces natin. So yung 500, okay? So minus 500 pounds. And ito, vertical forces din to. Gagamitin natin yung vertical component naman. So that will be plus 3/5 times 500. So wag niyong kakalimutan yon, may force dito na 500, same din dito, 500 din to. At kapag nag-summation forces vertical tayo, so kasali yon, always na kasali. So ano pa yung iba, yung 50 pounds na weight ng ating pulley. So yung weight natin ng ating pulley is 50 pounds acting downward. So minus 50 pounds is equal to 0. Okay. So solving for BV, BV will be equal to 250 pounds. So going to upward. Okay. So nakuha na natin yung BH and yung BV natin. So balik tayo dun sa ating beam. So lakihan lang natin ng konti yung beam natin. Gandahan lang natin ng konti. So kung ito yung beam natin, and dito yung point B natin. So kapag yung reaction natin dito sa pulley, papuntang upward and papuntang right side yung ating force. So kapag nilipat natin yung force natin dito sa B, magbabaliktad yung ating direction. So kung yung BV, kasi yung pulley natin is nakapatong sa ating beam, di ba? So ibig sabihin, towards dun sa ating beam yung force ng B horizontal tsaka B vertical. So yung vertical natin magiging downwards, okay? So this will be our BV. And kanina right side, kapag nilipat na natin sa beam, magiging papunta na sa left side yung ating BH. Okay? Ayun. Meron na tayong BV at saka BH. Ngayon, yung isa pang given natin is yung weight ng beam, which is 200 pounds. So, yung weight ng beam natin is 200 pounds. Saan siya nag-act? So, kung same lahat yung itsura or yung uniform, yung itsura ng beam natin, so yung kanyang weight will be nag-act sa gitna. Okay? So, sa midspan ng ating beam. So, yung weight ng beam is equal to 200. Okay? So, BV is equal to 250 pounds. And yung BH is 400 pounds. Okay. Ngayon, makukuha na natin yung ating reaction at C. So, dito meron tayong RA. And dito naman, meron tayong C vertical and V horizontal, C horizontal. Okay. So, using yung ating equation or summation moment, pwede nating makuha yung C vertical and C horizontal. So, madali na nating makukuha yung C horizontal natin. Magsa-summation forces along X lang tayo. So, summation forces X is equal to 0. Going to the right, positive. So, negative 400 plus CH is equal to 0. So, therefore, yung CH natin or C horizontal natin will be 400 pounds. And para makuha naman natin yung C vertical, pwede rin tayong mag summation vertical. Pero mas maganda na mag summation moment na lang tayo at point A para hindi na natin kunin yung value ng ating RA. Okay? So summation moment at A is equal to 0, clockwise positive, so that will be ano yung magmo-moment? So yung BV natin, that will be 250 times. So ano yung sukat natin dyan? So that will be 3 feet. Yung length ng beam natin is 3, 4, 5 is 5 feet. So that will be times 3. So from point B to point A is 3 feet. So that will be times 3. So this is 3 feet, no? Times 3. And ano pa yung i-moment natin? Yung weight ng ating beam. Okay? So ano yung weight ng ating beam? That is 200. So plus 200 times ano yung distance niya. So yung overall length ng ating beam is 5 feet. So this is 2 feet. So yung midspan niya will be 2.5. So that will be 2.5. Okay? Minus, so yung CV natin is upward. I-assume natin na upward. So magro-rotate siya sa point A. So negative siya, counterclockwise. So minus CV times 5. Okay? Is equal to 0. Therefore, solving for CV will be equal to 250 pounds. Okay? Going to upward. So, nakuha na natin yung CV and yung CH natin. So, ano yung required natin is yung RC or yung hinge force at C. So, pwede nating makuha gamit yung ating resultant force. Meron tayong horizontal and vertical. So, that will be RC is equal to the square root of CH and CV. So, that will be 400 squared plus 250 squared. So, RC natin is equal to 471.7 pounds. So, this will be our RC. And saan yung, para makuha natin yung direction, so yung RC natin will be nag-act dito. Okay? Upward. This is our RC. Para makuha din natin yung angle theta niya, kung saan siya nag-act. So, that will be theta is equal to inverse tan of ano yung vertical natin, that will be 250 over 400. So, yung angle theta natin will be equal to 32.01 degrees. Okay? So, yung RC natin is 471.7 pounds up to the right at 32.01 degrees. Okay? Okay, next problem naman tayo. So, a 12 feet bar of negligible weight rests in a horizontal position on the smooth incline. So, compute the distance x at which load T is equal to 100 pounds should be placed from point B to keep the bar horizontal. Okay? So, given is T is equal to 100 pounds. Okay? So, 100 pounds. So, hanapin natin yung distance ng x para yung bar natin will be horizontal pa rin siya. Okay? Hindi siya mag-i-slide papunta dito or papunta sa kabila. Kailangan horizontal siya. So, magkakaroon tayo ng reaction sa ating point A and point B. So, nakapatong lang siya. So, we will be having a normal reaction dun sa ating surface. So, perpendicular dun sa ating surface. Okay? So, ganun din sa kabila. So, meron tayong force dito na normal force at point B and normal force at point A. Okay? So, in this case, meron tayong vertical force downward and meron tayong papunta dito sa right upward and left upward. Pwede natin gamitin yung triangle force, okay? Para makuha natin yung value ng ating NA and NB. Okay? So, to get the value of NA and NB, pwede natin gamitin yung triangle or yung force triangle. Okay? So, pag meron tayong force triangle, so yung 200 pounds. So, this is 200 pounds. And meron din tayong T, which is 100 pounds. And yung NB natin is going to this direction. So, that will be NB. And yung NA natin, ayan, going to that direction, NA. Okay. So, kung 30 degrees yon, this will be also 30 degrees. And this will be also 30 degrees. So, yung magiging angle natin dito, NA and sa 200 pounds na P. So, this will be 30 degrees then. Okay. So, ito pala is 45 degrees kasi 45 degrees yon. So, this will be also 45 degrees. So, dito sa NA natin, NB pala natin will be 45 degrees. Okay? Kuha. So, pwede nating makompute using sine law. Okay? Yung value ng NA or yung value ng NB natin. So, kunin natin yung value ng NA natin using sine law. So, sa NA, so NA over, ano yung opposite angle niya? That will be 45 degrees. So, sine 45 degrees is equal to, this is 200 plus 100. So, that will be 300 over, ano yung opposite angle niya? So, that will be, so, kunin natin yung angle neto. So, yung sabi natin, triangle is 180 degrees. So, that will be 180 minus 30 minus 45. So, yung angle natin dito will be 105 degrees. So, this is 105 degrees. So, sine 105 degrees. So, solving for NA, so that will be NA is equal to 300 times sine 45 divided by sine 105. So, NA will be 219.62 pounds. Okay. So, meron na tayong value ng NA. Okay. So, para makuha naman natin yung X, so, to get the value of X, pwede tayong mag-moment summation at point B. Okay? Para hindi na natin kunin yung value ng NB. So, dito na tayo mag-moment. Okay? So, value ng X papuntang point B. From point B. So, magsa-summation tayo na moment at point B para makuha natin yung value ng X. So, given na yung mga forces natin. So, let's do this. So, summation, moment, oops. Ito na lang siguro sa baba. So, summation, moment at point B is equal to 0. That will be clockwise, positive. So, yung NA natin, that will be yung horizontal and vertical components ng NA natin. So, magkakaroon tayo ng force dito, vertical and horizontal. Okay? So yung horizontal force natin, hindi na siya mag-moment sa point B, no? Kasi same siya sa line of action. So dito rin 'yan. Dito rin 'yan. So yung horizontal ng NA natin hindi na mag-act. So gagamitin lang natin is yung vertical, yung upward. So that will be NA will be 219.62. So ano yung gagamitin natin? So yung angle natin is nandito, that is 30 degrees. So that will be cosine yung gagamitin natin. Okay? Adjacent dun sa ating angle. So cosine 30 degrees times, so yung length natin will be 12 feet, minus, so yung P natin 200 pounds, so positive to kasi yung reaction ng ating force is clockwise. Okay, so minus counterclockwise naman yung P natin, which is 200 times, so ano yung distance to? 12 minus 3, so that will be 9, minus yung force natin na T, which is 100 times X. So negative 100 siya kasi counterclockwise ulit. So times X is equal to 0. So masosolve na natin yung value ng ating X. So that will be X is equal to 4.82 feet. Okay. So next problem tayo. So a Fink truss is supported by a hinge at point A and by rollers on a 1:2 slope at point P. So the bracing bars are normal to the inclined members at their mid points. So the wind loads are perpendicular to AC. Determine the horizontal and vertical components of the reaction at A and B. So determine the horizontal and vertical components sa reaction ng at A and B. So meron tayong vertical reaction dito sa point A. So this is spin connection. So meron tayong A vertical and meron tayong V horizontal. A horizontal. And sa point B naman, so magkakaroon tayo ng normal force perpendicular dun sa ating incline. So this is a roller support. So magkakaroon tayo ng normal force. So this will be RB. Okay. So to get yung components nitong ating resultant ng RB, so meron tayong vertical force na nag-act din dito. So let's call this BV. And horizontal force nag-act din dito, that will be B horizontal. Okay. So yung slope ng RB natin will be the same kasi perpendicular siya sa ating incline. So this will be 1:2. Okay. So para makuha natin yung vertical and horizontal components ng ating mga reaction, so first mag-moment tayo dito sa point A para makuha natin yung RB. Okay? Yung BV and yung BH. So before that, kunin na muna natin yung mga distance ng ating trusses. So sabi niya dito, the bracing bars are normal to the inclined members at their midpoint. So itong bracing bars natin, normal siya sa ating midpoint ng ating AC. Okay? So kunin natin yung distance ng AC para makuha natin yung distance in between forces. So paano natin makukuha? So given yung whole size ng ating whole length ng ating truss and yung height niya, so using Pythagorean theorem, makukuha natin yung length ng ating AC. Okay? If we have 12 feet here, so ito magiging yung midpoint ng ating truss, so that will be 72 divided by 2. This will be 36 feet. Okay? So using Pythagorean theorem, so AC now will be equal to the square root of 36 squared plus 12 squared. So AC now will be equal to 37.95 feet. Okay? So, itong AC natin is 37.95 feet. So, sabi niya, midpoint yung kanyang bracing bars. So, 37.95 feet. So, divided by 2. So, yung length ng between forces natin dito sa taas will be 18.975. So, same din dito, 18.975. So, this will be 37.95 over 2. Okay? So, kunin naman natin yung value nito. Point dito, 8,400 pounds from point A. So, let's call this point M. So, same din dito. Let's call this point M. So, paano natin makukuha yung distance ng point M? So, meron tayong triangle dito, di ba? So, kunin muna natin yung angle theta dito. So, para makuha natin yung triangle M natin. So, gagamitin lang ulit natin yung Sokotowa or yung Pythagorean theorem. So, kunin natin yung angle theta. So, that will be, angle theta will be sine. Tama? Sokotowa, opposite over hypotenuse. So, pwede natin gamitin yung sine or yung tangent. So, tangent na lang. So, that will be tan theta is equal to 12 over 36. So, theta will be equal to 18.43 degrees. So, meron tayong value ng theta. Pwede nating makuha yung value ng M. Okay? So, kung i-isolate natin tong triangle na to, okay, meron tayong triangle dyan. So, this is theta and this is 18.975. So, sabi niya, so normal, bracing bars are normal to the inclined members. Ibig sabihin, this will be 90 degrees. So, right triangle siya. And ito yung M natin. So, given yung 18.975 and given din yung theta natin, alam natin yung theta natin, masosolve natin yung M natin using cosine. Tama ba? So, cosine theta is equal to, so cosine adjacent over hypotenuse. So, itong M natin, ito yung magiging hypotenuse niya. Okay? Adjacent, this will be 18. So, cosine theta is equal to adjacent over hypotenuse. So, that will be adjacent. So, that will be equal to 18.975 over M. Okay? So, solving for M, M will be equal to 20 feet. Okay? So, alam na natin yung value ng ating M. So, yung value natin dito will be 72 minus 2M. Okay? So, this will be 72 minus 2M. That will be equal to 32 feet. Okay. Ngayon, mag-summation moment na tayo at point A para makuha natin yung reaction at point B. So, summation moment at point A is equal to 0, clockwise, positive. So, ano yung may moment natin dito? That will be 8,400 pounds times M, that is 20 feet, plus 18,000 pounds times 32 feet plus M, that will be 20 feet plus 32, that will be 52 feet plus 3,160. So 3,160 times 18.975. That will be 3,160 times 18.975. plus 1,580 so plus 1,580 times 18.975 times 2, that will be 37.95. And then yung last is yung BV natin. So yung BH hindi na natin mai-rotate kasi concurrent siya sa point A. So yung BV na lang. So that will be minus, kasi counterclockwise, minus BV times 72 feet is equal to 0. So masosolve natin yung BV natin. So that will be BV, B vertical is equal to 17,000 pounds upward. Okay? So nakuha na natin yung BV natin. So kunin natin yung BH natin. Okay? So yung force ng RB natin is upward, di ba? So upward yung RB natin na may slope siya. This is 1 and this is 2. Ito yung RB natin. And so yung BV natin, nakuha na natin. So para makuha natin yung BH, sabi natin yung BV natin is equal to 2 over, so ano yung hypotenuse nito? That this will be square root of 5. Okay. 2 over square root of 5 ng RB. So given yung, alam natin yung BV natin, makukuha natin yung RB natin. Okay. So BV is 17,000 pounds. So that will be 17,000 pounds is equal to 2 over square root of 5 RB. So makukuha natin yung RB. RB will be equal to 19,006.58 pounds. Okay. Then makukuha na natin yung BH natin. So yung BH natin will be equal to 1 over square root of 5 RB. So BH now will be equal to 1 over square root of 5 times 19,006.58. Therefore, BH natin is equal to 8,500 pounds. So, yung direction nito will be going to the left. Okay? Ayan. So, nakuha na natin yung B horizontal and yung ating B vertical. Now, kunin naman natin yung A horizontal and A vertical natin. So, saan tayo magmo-moment para makuha natin yan? So, pwede na tayong summation. Pwede tayong mag-moment at point B, or pwede rin tayong summation horizontal or summation vertical. Okay? So, pwede tayong mag-summation vertical na lang, or pwede rin, kasi kung magmo-moment tayo dito sa B, so kailangan natin kunin yung mas mahirap siya, no? Kailangan natin kunin yung horizontal and vertical components nitong inclined forces natin. Okay? So mas maganda same lang din naman yung gagawin natin. Kailangan din natin kunin yung vertical and horizontal components ng wind loads natin dito sa truss. So summation forces vertical na lang tayo. Okay? So, summation forces vertical. So, i-resign lang natin to. So, mag-summation forces vertical muna tayo. So, summation forces vertical is equal to 0. Upward, positive. Okay, so that will be AV minus, so yung vertical components ng 1580 natin, so that will be, so yung class, yung slope nito will be, kunin natin yung slope nito. So this will be 3:2. Tama ba? So kung ito ang slope natin is triangle natin, 12 yan. This is 36. So pwede nating i-simplify. So that will be, parehas din siya sa 3:2. Tama? So 3:2. So itong hypotenuse natin will be square root of 10. Okay? Therefore, ito is 3 and 2 din ito, and square root of 10. Okay? So yung vertical components niya, that will be 3 over square root of 10 times, so yung muna 1580. So pwede na nating pag-aadin lahat ito. So plus 3160, pare-parehas lang yung kanya, plus 1580 ulit doon. Okay? Minus yung 8,400 kasi downward siya. So that will be 8,400 minus 18,000. And yung BV natin, which is minus BV, that will be, ano yung BV natin? 17,000 pounds. So minus 17,000 pounds. Therefore, yung AV natin, AV is equal to 1,500, 15,395.68. Okay? So, nakuha na natin yung value ng ating A vertical. Okay? So, this is the value of A vertical. And then, solving for A horizontal. So, pwede tayong mag summation forces horizontal naman. Okay? So, summation forces horizontal. So, burahin lang ulit natin to. So, summation forces horizontal is equal to 0. Going to the right is positive. So, AH is negative. So, that will be AH. So, negative AH. So, minus yung horizontal components naman, yung forces natin dito. So, yung gagamitin natin is yung 2. So, that will be 2 over square root of 10 times 1580 plus 3160 plus 1580. Okay? So, ano pa yung ibang force natin? So, yung BH. So, yung BH natin will be negative ano yung BH natin? So, BH natin will be 8,500. Will be negative 8,500 is equal to 0. So therefore, yung AH natin will be equal to negative 6,501.44 pounds. Okay. So negative siya, class, kaya dapat yung direction ng AH natin is papunta sa right side. Okay. So hindi siya papuntang left side. So papunta siyang right side. So AH, so yung AH natin, AH will be equal to 6,501.44 pounds going to the right side. So this will be our AH. Okay.